Okay, question 12. A yacht sails on a bearing of 138 degrees for 3.2 kilometers. The yacht then turns to sail on a bearing of 270 degrees. Calculate the distance the yacht sails in its direction till it's due south of its starting position. Okay, so with this question, you're going to need a diagram. Okay, they've actually helped you here to give you a sort of format for the diagram. If they didn't, you'd still need to draw a diagram. So important. So you can see here, start position. That's the most important point, of course. And then you've got this arrow pointing you towards the north. Now, just because that arrow is there doesn't mean that's where the yacht is going. It's just, that's to help you with the bearings, okay? Because bearings are measured in a clockwise direction starting from the north, okay? You don't need a protractor because it's not drawn to scale. But if you look here, it says the yacht sails on a bearing of 138 degrees for 3.8 kilometers. So there's the start. This is your 138 degrees here. That looks kind of like 138, doesn't it? Okay, because it's more than 90, but less than a straight line, less than 180. So the yacht sails on a bearing of 138. 138 measured from the north. So there's the north direction. 138 means it's going this way. Okay, 138 degrees bearing from the north for 3.2 kilometers. So we know this here is 3.2 kilometers. So it gets there, and then it says that it turns on a bearing of 270 degrees. And if you think about it, if we've got a north line here, okay, the north line here, it's pointing this way now, but it turns on a bearing of 270. So it's all about bearings, and of course, bearings from the north, measured 270, would then give you this direction, if you think about it, because that is 270 there, and that's 3/4 of a circle, okay. So then it would be going that way if it's turned on a bearing of 270. And then they want you to know the distance from when it's directly south of here, okay, south of its starting position. Now what's good is this here obviously is going to be 90 degrees, okay, simply because of the makeup of this here, the fact that it is going on a bearing of 270 from here, which means that this is perpendicular to this line here, okay. Just looking at the symmetry of it, okay, and the parallel lines here, the north line here, the north line here, so it's got to be 90 degrees. So you've got yourself a triangle, okay, and they want the distance from here to here, so they want this distance here. Now, it's a right angle triangle, you might be thinking Pythagoras, but Pythagoras would only work if you know two sides. We only know this side, we don't know this side. But we do know the angles. We know that's 138, which means we know this here, of course, it's got to be 42, because it's a straight line, adds up to 180. Then you go and use your SOHCAHTOA. Okay, so we don't use Pythagoras, we use SOHCAHTOA. Now, of course, there's a right angle, so this is your hypotenuse here. This is opposite that angle there, and then of course you're adjacent there next to the angles. Okay, now so we write out SOHCAHTOA. H is what we know, and we want A, so A and H, so car. So cos 42 will equal to adjacent over then the hypotenuse, which is 3.2. And then to get A, you just got to take that 3.2 up there and multiply by the cos 42. And you get your answer, which will be 2.4 kilometers rounded to one decimal place. They've given that to one decimal place, so I draw my answer to one decimal place as well.